Sudoku degenerates, welcome! I have once again gotten off to a very late start. Hopefully this should be the last time for that. Promises, promises. Also, starting next week, I will be adding some more point redeems as well. So this is the new Rat Run. Experiment 27. Today I finally got a chance to watch the tapes back. The only camera that had captured anything remotely interesting was the one I'd hidden on top of the bookcase. Fast-forwarding through mostly dull footage... Hi, Isaiah! Of him at his desk, something eventually caught my eye. At one point, he got up and started scribbling calculations on the blackboard, before drawing 3 large circles in what looked like the letters SRT. He stood back and looked at it for a full 5 minutes as if contemplating. This had all been rubbed off by the time I arrived the next morning. SRT. Does the T stand for teleporting? I guess we'll find out. Okay, this is Rat Run 27. Normal Sudoku rules apply, so every row, column, and box, each of these 3x3 boxes, I gotta put 1 to 9 once each. Aim of experiment. Finks and Finks must both reach different cupcakes by finding a path through the maze. The paths must not visit any cell more than once, cross themselves or each other, or pass through any thick maze walls. As well as moving orthogonally, they may move diagonally if there's 2x2 space in which to do so, but may never pass diagonally through a round wall spot on the corner of a cell.
What fate a slug cat?
So that's okay, but that isn't. Golden berries. If 2 digits are joined by a golden berry, they are not consecutive. Golden berries. Are those gold raspberries? We have some of those here, but you can't get them in stores because they're so fragile you can't ship them. So you have to grow them yourself. They're delicious, though. Test constraint. In this experiment, both paths are divided into segments by 3x3 box borders. Along a path, the digits on each segment have the same product, the result of multiplying the digits on the segment together. This product may be different for Finks and Finks. I'll ask Marty at some point. Note: if a segment contains only one cell, that digit is considered to be the product. Okay, so Finks cannot just take that cupcake because then these would have to be the same digit. So, okay. If I... 2 times 3 times 4, 24. The only way that Finks takes this cupcake is by going through here or here, because anything else will cut off Finks from reaching either cupcake. Now, the question is, if Finks goes through here, minimum I can make this is 1, 2, 3, 4, 5. And 24 times 5 is 120. But 9 times 8 is only 72, so that will not work. And there's no way for any rat to take more than 2 cells in this. For whichever rat gets this cupcake to take more than 2 cells in this box. So it must be Finks who takes this cupcake, but must take a more roundabout route and can't go this way. So Finks goes this way, but if she goes down here, then she cuts herself off. Oh, unless she goes around here. But no, because she'd have to come through. Right, so the long shot is Finks can never take more than 4 cells in a box, and even 4 is pushing it, so she can't go down here. So she has to go here. And if she comes up here, that's more than 4 cells, so she must go this way. Now, since her path can't cross here, she must go down this way. Well, I actually don't know, because she has 1 more degree of freedom. Yeah. Oh, and this is interesting. Now Finks also can't take more than 2 cells in this box. Oh yeah, this is forced. Okay, so I think... Well, regardless, Finks... must go here. And so Finks must go here, but cannot immediately go up. So she must take at least 1 more in this. Wait. A single digit... Oh, it's a single digit product. Okay, so Finks never takes more than 3 cells. And there must always be a 1 on there, because 2 times 3 times 4 is already more than a single digit. And Finks either goes like this or like this. There must be a diagonal here or here. And there must always be a 1 on here. Yes, 6 or 8. And they're all... and a 2. In fact, these must be the same 3 digits. These are 1, 2, 3, or 1, 2, 4. Ah. And this digit is this digit. Okay. So this cannot be consecutive with either... It's 4. So this is 8. And Finks must take 3 here. So this is 1, 2, and... I think... Since Finks can't read... I think Finks has to go up here? And the other of 1, 2, 4 is in here. So, this is either 1, 8 or 2, 4. Now, it is theoretically possible to take 3 cells here. If it's like... one of these. I don't know... Well, this is 1, 2, or 4. If it's here, it's 2, 4, so that would also be... Right, so this is always from 124. Because if it's only 2 cells, it can't be 1/8, so it has to be 2/4. Okay. There's also a 4 down here. Oh, and what's 2, 3, 4, 5? Yeah, that's 100. That's too much. So there must be a 1 on here, on wherever this goes, and it can't be here, so there must be a 1 here. Oh, this is 1, 2. This can't be 1 or 2. So this is 4 or 8, so this is 1 or 2. Ah, 1, 2 pair here makes this a 4. Oh, this is 8. So this is not... I guess the only thing this Goldberry tells me is that this isn't 3? I'm curious why this Goldberry is here, because... it must be just to rule 3 out of here. Now, okay, the minimum I can make this is 2 times 3 times 4. That's 24. Okay, I'm still... and the max I can make this is 72. That is still a lot of... So there's a 1 up here in this box. And there's... oh, this can't be 1 or 4, so this has to be 1 or 4. So it goes like that. Oh, and this makes this a 2. Oh, and neither of these can be 1. Okay. Hey, Dorlier! So, yeah, Finks's path is done. So there's a 1 here. Now it's just Fing. Ah, going good. Okay, so these dots do kind of restrict exactly how much... oh. Okay, I didn't even need this to get this, because these dots, they mean that... oh, no, it would still be possible for Finks to only take 3 cells in this box if she exits and then re-enters this. That would be very tricky, but theoretically doable. Okay, so I need to... I guess 2 in this box only goes here. Oh, wait, this is a 2-4 pair in this box. So this is 1. Now, if Finks takes 4 cells in this box... Oh, can't have a 2 or 4 on there. Doesn't that change? Oh, I could have a different even, 6 or 8. That might change the... Oh, I could also do this. Something like that. 3, 2, 2, 4. That would be... Have this digit here, this one here, and these two be the same as these two? Yeah, that's... Now, but I know this doesn't have both 2 and 4 on it. Because this can't take this cell. It either has to do that or that. So the minimum sum I can make is 30. Minimum product, sorry. Minimum product I can make is 30. 3, 5 here, 3 and 5 in here. But if I have a 5, because of prime factorization, if I have a 5, I need a 5 in every... Of course, that's assuming it's 3 cells. It could just be... Wait, can I make... The prime factors of 30 are 2, 3, and 5. So I could have a... Without 2, I would need either a 10 or a 6. Can't have a 10, so I could have a 6. But then I'd also need a 5. But that's... If I allow myself to get bigger, that opens up more... What is this? It's 3, 5, 6. It's not 7 or 9. But if I only take 4 cells in here, I can't immediately go enter this box, or it breaks. because I can't put a 1. 1 in this box only goes here, and if I only take if I take exactly 4 and then exit, I can't take either of these and then enter here while only taking 4 in both. Okay, so if I take 4 in this box, I have to re-exit this. If I take 3, I also have to enter and re-exit. Okay, so I think I've just proven that I need to enter and re-exit, that I need to exit and re-enter this box. Now the question is, can I prove that it doesn't do something like this? Huh. Am I correct so far? Okay, so I am correct about this. The only question is what... I'm very curious, like... I don't think... If this is 2, 3, 5, that doesn't work, but what if it's something else? Oh. 2, 3, 6 doesn't work for 2 cells. Okay, so it's not 36 because this has no value if it's 36. Two, 3, 7 makes this 6, 7. Nice. That feels like I could see that being a plot reveal, that one of these is The Hitchhiker's Guide to the Galaxy. That one of these oh, and also written here, 42. It would make this 3. How would I do that in 3, though? Would it have to be 1, 6, 7 each time? Is there no other way? Or what if this is a 4? 3 times 4 times 5, that's 60. Which which you can't do in 2 cells. Okay. 3 times 4 times 6? Oh. That's 72, which would make this 8, 9. If this 4, 3, 6... 3 times 4 times 6. So if this isn't 2, if this is 4, then this is 5, and we got a 3, 6 in here. Two, 2, 2, 3, 3. I could make that 1, 8, 9. That would be tough to do in 2, but... Oh, could I do it without 2, 4? What's 72 divided by 18? Oh no. 9 times 8 is... Oh, 4. 18 times 4 is 72. I don't think you can make 72 with 3... Oh, but if it's going up here... Something like that? Huh. So if this is 4, this is 5, this is an 8, 9 pair. That may be the only way, because I think the only options... 30 makes this a 6, 5. 36 breaks. It can't be 2, 3, 8. And if it's 2, 3, 9, 9 times 6 is 54. Now, is there a way... Is there multiple ways to do that in 3 cells? $54, it's... Two, 3, 3, 3. Could be 1, 6, 9. Or 2, 3, 9. So I think... But if it is 2, 3... Could I have an 8 on there? Could I make it something that is divisible by 8, so I could put an 8 on here in this box? That might... I think the only other option after 54 is 72. Now 30 in 2 cells is only 6 by 5. Each of these, I think, only has one way to write them in exactly 2 cells. So this is either 5, 6, 6, 7, 6, 9, nice, or 9, 8. But wait. Wait. 3, 4, 5. That's not 72. That's 60. But there's no way to do that in 2 cells. So no, it is 2, 3, 6, 72. Never mind. Oh, but what about... 2, 4, 5. Oh. Right. I should open up a notepad. I can use power toys to keep this on top. Not what I meant to do. Wait, what is the shortcut? Oh, it's when Control T. Okay. So, 2, 3, 5, 30. $36 is not an option. Next is 42. Two, 3, 8 is obviously not. Yeah, it can't be 48. Oh. Oh no, that requires 2, 4, 6. Because I can't put both 2 and 4 on here, or 8. So, oh, but if I put 4 and 6... Oh, but I need a 2 to get to 48. Yeah, 48 is not an option. So, I need... So I can skip that and go to 239. That's 54. So, and once again, there's no actual way to, you can't write it in 3 multiple ways without using a 1. So that does limit my options here. And okay, what about 2, 4, 5? That's 40. 8, 5. Oh, but I can't put 2, 4, 5. I can't put 2 and 4 on there. What about 2, 5, 6? That's 60. But there's no way to do that in 2 cells. It'd have to be 5 by 12, 10 by 6. Yeah, it has to be something bigger than I can actually do. Two, 5, 7 is 70. That's also not factorable in 2. Oh, I should also... Right, so it needs... If it has a 2, it needs a 3. And... 4, 5, 6 is too big. Okay, so there's always a 3 on here, so this is never 3. So if I skip 2, can't be 3, 4, 5, because 60... Oh, but if it was... No, that... 60 still breaks up here, so it would... So the only... Right, there are only 4 options. Now, is there another option for... Nope. I can't have 2 6s in the same box. Or 2 3s and an 8. So, whatever I make, there is exactly one way of making it in 3 cells if I can't use a 1. And if I can't use a 1... Right, so I need to take... but 4 cells needs a 2 or a 4 in every case. So it needs to be 3 with a 1. And the only way to take exactly 3 in this box is if I do this. And these 2 digits must be the same as these 2. Now there's no way to... Right, whatever I take in here, it must be either... If I take... Okay, so there's no way... It has to take the long way around. Oh, and once it gets down here... Because if it goes like this... There's no way... Yeah, that doesn't work because these digits would have to repeat. So it does go here, and either takes a... It either takes 3 or 4, so it is... Oh, and it has to enter here. Right, so... The 2 and the 4 cannot have any digits in common, so it must be 72. 3, 4, 6, and 8, and 9, because otherwise I'm going to repeat a digit on the path in this box. This is a little interesting. Oh. Oops. Right, and this pretty much has to... Well, no, it could still have a 1 if it's here. Oh, but wait, no. If it takes this... Right, it has to take... It has to go like that. And since that's 8, that's 9. But what does it do up here? Well, it can't go this way, because it's either 189 or 346, and either way breaks this. So it does have to go up this way. But that could be... but this can't be an 8-9 pair. And the one's up here. So I think it does... Oh, this is 4. So there's a 3 and a 6. Right, this is 5. So this is 7 or 9. And I guess 9 in this box must go here. 9 in this box must go here. If there's a 6 on here, there must also be a 3. So if there's a 3 here, there must also be a 6, for what that's worth. Okay, this is 1, 3, 4, 6. Oh, none of these are 1s. Okay, so these are 3, 4, 6. Now, does this have to... Well, I can't take... Okay, so... If this goes up, we're in trouble. And if this goes this way, it has to go up, but that... Yeah, this can't reach 3 cells. Oh, it could be... Oh, it could just be a 3, 4, 6 triple here. So that still works. But this cannot be... Oh, this... It has to take 3 cells on its way down here. So this is... Oh. This is not the 1. And it does exit this cell immediately. So it takes 8, 9. Okay, so this is 8, 9. Right, regardless of whether it goes through here. And I think it has to, right? Because if it takes up here, we're in real trouble because it can't be anything that can be that way. Okay, so... what's left in here? 3, 6 pair. So I guess I can't take all of them here. And this is 1, 3, or 6. Wait. Oh, 3, 6, 7. Where does 7 go in this row? Goes here. And I know there's 1, 3, 4, 6 in here. So I guess this is only 2 or 5. It's not 2, it's 5. So where does 2 go in this box? This is not 1. Okay. So this is 1, and I know that it takes these. So this is 1. Right, and I know that it takes a 3, 4, 6 triple in here. Okay, this is... And there's another 3, 4, 6 triple in here. These 2 digits go in this column in this box. But there's no roping here. Oh. 2 and 7. That does create an X-wing on 2s, which forces 2... Wait, what? I have made a mistaken assumption. 249. Okay, well, I have... I guess I did arrive that way. Oops. Yeah, I can't use 2-4 here, so I think this was correct. Oh, but wait. Could I put a 9 here and a 2-4 pair here? That would lead to a deadly pattern, and not necessarily. It does mean this is 4. This is 2. This is 3 or 6, and there's 3 and 6 here, so that's 5. This is 7 or 9. And the other of 7 or 9 goes in whichever of these is not on the path. Wait, was I? No, there's no other way. 2, 3, 9. Yeah, there's no other way of getting... You can't make... Yeah. Okay, so I was correct to get these out, but... Okay. And I know it leaves here, and I know it goes up here. Now, if it enters this box, it must keep going until it's taken 3, but either of the ways of making... Yeah, I'm a little, it would have been cool. But I guess maybe... Once he'd picked the... Maybe he started from the locations and found the most interesting logic was to this. Yeah, I think this still can't go here. So it does go up here, and this is either... Right, and this still needs... Right, and this still needs... Oh, wait. These can't have any... This still needs to enter and re-exit, and they can't have any digits in common. Right, so 249 is out. So I was correct. This is 346, which does rule... Okay, so I took a little while longer to get there, but it does get me that. Oh, this is also 3, 5, 6, 7. This is not 5. This is 8, 9. Oh, and this also needs to be from 1, 3, 4, 6. Oh, I may have been mistaken in rolling 7 out of here, actually. Oh, and this does have to be 7, because I need 3 and 6 on here with the 4. So 2 in this box does go here, and 1 goes here. Okay. There's 4 with 3, 6, so I can't put both 3 and 6 here. So this becomes 3, 6. That's 5. And that is the other of 7, 9. Oh, makes it a 7 by Sudoku and a 9 there. Oh, this digit goes here and down here. So this digit goes here, for what that's worth. Oh, and I can still resolve the 1s like this. So this... Yeah, there's an 8-9 pair here that does force... And then... Right, now if this goes up, we're still in trouble with... well, okay. 2, 7... That makes that a 2. Okay. So this becomes... There's a 4, 9 here. 9 here. Oh. 4 and 9 in this box. They have to go here. And now, okay, since there's already a 2 here, this is another 3, 4, 6. So... Three, 5, 6, 7. This isn't 3, so it's 5, 6, 7. Oh. This isn't 5 or 7, so it's 3, 6. It is blue 3, 6. So this now becomes an 8, 9 pair. I guess this digit goes here for what that's worth. Oh, this can't be 3 or 6, so this is only 5 or 7. Green goes here, so it goes up here. Oh. But I can only take 3 more. Okay, okay. I have an X-Wing on 4s. Oh, neat. Maybe link me to that one. I'm gonna try that at some point. So this must be 4. Yeah. Okay, so this is 4. So this is green 3, 6, which does not go here. And blue does go here. That is, but that doesn't, it could go this way or this way. So there's an 8, 9 in here. 8, 9, 3, 4, 6. 2, 5, and 7 left over. That's a 5. That's a 7. Oh, so this is 3, 6. So it's specifically green 3-6, which makes this 4. And now we start to unravel this long chain of deadly-looking patterns. So there's a... Oh. This digit goes here. This is green, this is blue. And there's a blue in here along with the 5. Oh, this is a naked 7, I believe. Because it sees 1, 2, 3, 4, 5, 6, 8, 9. Yeah. Cool. I might not have time for it today, but I should in... Oh, if this is blue, it's 6. What else is left in this column? Wait. Oh, it's 3, 6, 8, 9. Well, this is only 8, 9. Okay. Oh, this is only 6 by Sudoku. So, that makes green 3, blue 6, and 3 is here. Okay. Okay, so both rats' paths are done. Hey, Fronature. Welcome. Oh, what's left here? 2 and 7 resolved. And that leaves this a 3. So this is only from 5, 6, 7, so that can't be a 6, so that's a 6. So that's 3. One last 3, I believe. Yep, got all the others. Okay, can I do... What about 6s? That's a little trickier to... Oh. Okay, that's 5, 7, 5. That's 5. Oh. I was wondering how I would resolve these. Oh, yes. Hadn't even looked at that in eons. Probably would have, Cool. Perhaps I've been spending too long in this lab, but I have a funny feeling I'm not the only one keeping an eye on Elliot. Finks also appears unusually attentive towards him. Several times I've caught her sitting there when he approaches, looking up at him with a sort of curiosity and compassion, something I've never noticed from Finks. Oh dear, is there going to be division between the rats regarding which of the researchers they side with in the upcoming conflict? That would be sad. But yeah, that was neat. I agree with 4 stars. But yeah, that is that was fun. All right. All right. Okay. Juggler suggested this. It's got its own itch page. I need to I think yeah, I should refill my water. Alright, I'll add this to the queue. Yeah, this does look cool. Alright, I'll be right back. Alright. Yeah, I saw it at its own website. Ah, programmed in Godot. Yeah, neat. A non-Euclidean variant Sudoku. Control click, add to selection, shift, corner pencil mark tool, control center pencil mark tool. Okay, so it's the same as an alt color pencil mark tool. Control Z, undo. Okay, so that. So, what makes this non-Euclidean? Greetings from the Dutch city of Leeuwarden, birthplace of... I'm only guessing as to that pronunciation. Hey, juggler! Birthplace of renowned artist MC Escher. Oh, cool. I love his artwork. You've been contacted by the city's municipal planners, asking for your assistance in designing a layout for their new downtown center. You are quite eager to get to work as you look over the list of requirements the planners have tasked you with, but as you are reviewing the map of the project, you notice something strange. The geometry... Oh! Hey, welcome, Raiders! Hey, AQ, and Dubious Mobius, and Finks. This is a, quote, non-Euclidean Sudoku. It has its own webpage and its own app programmed in Godot. I am very much looking forward to seeing exactly how that works. The geometry of the city is quite unusual. The project area comprises 12 blocks that are each divided into 9 lots. You've been assured by the City Council that rows and columns in the grid, collectively ranks, are perfectly straight and intersect at 90-degree angles, despite your map showing them zigzag. But that's not possible in Euclidean space, you try to tell them, but they laugh off your concerns. City ordinances require some blocks to be reserved for use as public parks. You will need to designate some blocks as parks such that each rank passes through exactly one park. Rows and columns... Oh, rows and columns are called ranks. With a lot suggested, use the tree button to toggle its block to from a park. Okay. The rest of the blocks are to be used as city blocks where various skyscrapers are constructed. Wait, are blocks... Oh, 12 blocks that are each... Okay, blocks are boxes. Oh, no worries, no worries. Might want to use... Okay. The rest of the blocks are to be used as city blocks or various skyscrapers are to be constructed. The number in each lot represents the height of the skyscraper that will be constructed, with 1 being the shortest and 9 the tallest. Place the digits 1 through 9 in all the city lots such that every block and rank contains a skyscraper. Good night, Stu! Contains a skyscraper of each height without repeating. Note, do not place any additional digits in parks. Given digits within parks are not skyscrapers and don't count towards the rank requirement. Okay. Right, that's why these... Okay, so I've got to assign... I see where the... Okay. Given digits within parks are skyline clues. They represent the total number of skyscrapers that must be visible from that location in all directions. Okay. Right, they're outside the grid. Okay. Taller skyscrapers block shorter ones from view. Okay, so this sees... Okay. 7, 8, 9... Okay. Combining all directions, this makes 9 skyscrapers visible, making this a valid skyline clue. Okay. You can select a skyline clue to see which skyscrapers are visible. This can be disabled in the settings if desired. Okay. After determining which blocks should be parks and filling in the rest of the grid with buildings, you should be left with a valid grid like the one here. This puzzle has an intended logical solution with no guesswork required. The city of Leeuwarden is depending on you. I should look up how to pronounce that. Leeuwarden, or whatever it's called, pronunciation. Oh, I was Leeuwarden. Leeuwarden. Okay. Okay, I wasn't that far off. Just needed to unelongate the E. Okay. Yeah, okay. Alright, so every rank has 12 cells, so it needs a park to get down. Okay, so if this is a park, that'd be pretty convenient for the 9 in this rank. I'd also need a 9 here, or just this would have to be the second tallest digit it sees, which in this case couldn't be 8. So, okay, maybe I should... Are there any givens that see the same digit in their rank? Can one ever be in a park? Oh, that's... It would require... Oh, no. Right. It sees... In fact, nothing below 4 can ever be in a park. So these are not... So I know this is not a park. Oh, wait. This could be, because it doesn't see anything here. But this isn't. What about... If this is a... Oh, wait, no. This can't be a park, because that requires a 9 here. Because that requires these are the only... These have to be the highest visible, and this would always see this. So I don't think this can be a park. I mean, this wouldn't have to be a 9 specifically, but it would have to be... Like, this would have to be an 8-9 pair if this was a park. So I don't think this can be. So one of these two must be. Otherwise, this rank doesn't go through a park. Oh, right, one of these two must be, and they both look into here, so this is Never Park. So one of these two must be, so either this is a park or these are both parks. Now, if this is a park, now there's nothing that, let's see, hey Abyss, and thank you. If this is a park, this is a park, and then I think this has to be a park. Whereas if this is a park, there's one on here, so this is never a park. Yeah, that is a neat touch. Ooh, three next to 9 is interesting. Oh yeah. Yeah, this is just barely, like, if it just sees, like, one here, and then I can have one left over here. Or it sees 2 here, and I have 2 degrees of freedom down here. Oh yeah, we have 2 of those. If this is a park, this isn't a park, so this is not 7 or 8. Max, this can be a 6, so I'd have to put the 9 somewhere in here. Is it interesting that both of these 9s have an 8 in the 8th spot? Well, yellow means it isn't a park, so it doesn't need to be... So this 8, it's just a digit. It's just a given digit, it's not... If this isn't a park... then this is an 8. if these are parks, then this is 8. Just by Sudoku. Now, if this isn't a park, then this is... no worries. I meant, each block has exactly 2 givens, so there must be, like... Okay, this is 4, this is... It sees 2 this way, so it must also see 2 this way. So if this is park, then this must see exactly 6 this way, and this 9 here... that doesn't... no, that's just... This would have to be almost strictly descending. There'd have to be exactly 1 hidden digit in here. This can't be a 4, so this would have to be 2 or 3. This would have to be 1 or 2. Oh, and I can't have a 6 in here. So this couldn't be 5. And the only other option... Okay. So if this is a park, this is 1, 2, 3. This is 4, 5. Wait. Oh. I don't think it works for this to be a park. Because without being able to put 6 or 7 on here, I think this is 1, 2, 3. And without this being able to be a 5, I think that breaks. Because with no 4 here, and no 6 or 7 here, I can't put a 5 here, so the only... Yeah, 3, 2, 1. That's all forced. Oh, the 5 could be an outside clue. Okay. So this would be 4, 5, 8. Yeah, that works. Which makes me suspect that's what it is. This is a park, this is park, this is park. No, because of this 4. Because if this is park, The 4 sees exactly 2 in this direction, so it must also see 2 in this direction. So this 8 sees 2 in that direction, so it needs to see exactly 6. Oh wait, no, that's... Right, I neglected to account for the fact that there's a hidden digit here, so even that is incorrect. Oh. Okay, if this is park... Oh yeah, if this is park, then this is 8. But also, this 6. This either sees exactly 1 or exactly 3 here, so it needs to see exactly 3 or exactly 5 here. I don't think there's any way for it to see exactly 3 down here. So it would have to see exactly 5. Not with a 7 here and an 8 after it. It can't see... This 6 can't see exactly 3 down here, so it would need to see exactly 5. So this would need to be a 9. But if this is park... then this is 9. If this is park, then this is park. So these... Okay, so if this is park, then this is park, and these do all need to be in strictly ascending order. That makes me suspect that's what it is. And this is also park. Are there only 2 layouts for parks? Okay, we got this, this, and this. Right, if this is park, this is park. And if this isn't park, then these are parks. So this is never park. And neither is this. Oh, dang it. I thought this was so... This being park would be so forcing. Oh, well. So it's either here or here. Ah, yes. If this isn't park, then this is 8. Yeah, it doesn't need an 8. Yeah, we can... As soon as we know the orientation, we can place all the 8s. Like if this is not park, then that isn't park either. So we've got this and this. And this. And in the other world, we've got that. And in fact, one of these 3 9s must be a skyscraper pair. That is very interesting. In fact, these are symmetrical, so exactly one pair of each of these must be... Yeah, center mark's probably better. All right. If this isn't a park, one of these is 4. Now, can this... Now that I know this isn't... Or, okay, this 7. If this is a park, we've got an 8 here. So that's 1, a max of 3 here. That's still pretty... That's still a lot. Oh, and this... Oh, it'd be exactly 3 here. Because if this isn't a park, this cannot be 9. So I know that... Oh, I don't know that the 9 is here, though. It could be here. So it could be just 3 here with a 9 up here. Yeah, 4 and 8 are the only... This 4 and this 6 are the only things that break symmetry in the entire puzzle. So they must... Yeah, everything else is totally symmetrical. So there must be something that... If this is a park... This is 8, and there's nothing else. There's no 9 in these because of this, so that just sees 1. Now what about this? Could this also be a 9? Oh no, because it sees this. So it's less than this, but the 9 in this rank could still go here. Especially because... Oh wait, no it can't because of this 3. Okay, so it sees 4 up here, and then 6. Huh. These must be the key to resolving it, because they're the only thing that breaks any symmetry at all. So, what is the issue if... Yeah, maybe that is the thing. Okay. If this is a park... This is 8, and there's no 9 here, so that only sees 1. This is less than 9. The 9 could still be up here. Yeah, it's a Necker cube illusion. Okay, so this sees either 2 or 3 in this 1. So we're at 3 or 4. 4, obviously this is not going to be the highest one it sees. But, oh, especially because I know the 9. Well, the 9 could still go here. 2, 2, 1, 1. That's 6. That's exactly 6. So I'd have 1 degree of freedom. But the thing, okay, and it gets used up here because this can't be 9. So I think this has to be 9 if this is a park. Because of this 3, because if this is park, then this is also park. And so is this. So this is 8. I think this has to be 9. And because there's a 9 in here that otherwise this 3 is broken. Or wait, no, this could still be, no, this can't be 7. Yeah, I can't have 9 at the end. Okay, that works. What about this way? Does this break? Now, this 7 sees 1 that way. Oh, neat. I guess the different colorings I've been giving them. Okay, so this is 8 in that world, so is that, so is that. Oh, maybe this 6? Hang on. Nothing to be sorry about. This 8, there's no 9 up here. So there's a 9 here, so it sees 1, at least 2. So we're at 3. And this can't be 9. And how about wait? This can't be 9. So let's see, yeah, this is satisfied either way. What about this, though? Well, Sudoku Maker doesn't allow oblong cells, and I think Penpa, it allows a single cube, but you can't get multiple cube shapes like this, so I don't think Penpa would let you do this either. Oh man, a dice maze would be very interesting here. I wonder how I would handle it at the corners. Oh, wow. I just thought of... I just thought of something extremely evil. I could use the powers I made that dice maze Sudoku for. I have no idea if it would work, but it would be... Huh, are there hints provided? No. I am a little stuck here, I admit. Does... Yeah, highlighting definitely wouldn't... Sure, let's just... Okay, let's assume these are the arcs. Okay, yeah, let's go from here. Okay, so 3 in a park and no 8 here. Obviously, this has to be, this can't be 9. So it has to be lower than 8 and 9. So the 9 has to appear before the 8. And because this can't be 6, 7, or 8, it has to appear before the 6 as well. So there is a 9 in here. Because, oh no, it could be 9. Right. Then this could be, then it could see 2 this way. If this is 9, this pretty much has to be 9. Yeah, it needs either a 9 here or a 9 here. Well, okay. If it's 9 here and 9 here, this 6, it sees 2 here, so it must see 4 here. That doesn't work. Okay, so that's forced. There's also a 4 up here, for what that's worth. So, this is... Right, the 6, it says... Well, this... I can't put an 8 here. Or a 6. Okay, so this sees either 3 or 4 here. So it sees 2 or 3 here. And it must see 3. Yeah. Okay, so it sees 3 here. So this must be higher than this. But, because this... Okay, so I need to see... Wait, I think this is broken, isn't it? This 9. It's impossible for this 6 and this 9 to both be satisfied. Okay. So it must be this way around that the parks go. But won't I run into the same problem? Oh, wait. Okay, wait. This sees 1 here, so it must see 8 here. But how is this higher than this? Oh, there's a 1 up here. Yeah, okay. So this is 2, this is 1, right? Well, that's what I was looking at. I just thought it wasn't... Okay, so yeah, the 1 must be hidden. So everything else must be ascending. Now, I don't know that this is a 5. I think this is either 1 or 5. And I know this is a 9. Because it's the only place... I think this is 1, 5... Oh. This is 5 or 6, because it can't be 1. Go down from 9. Oh, this. That has to be 5. Assuming... Assuming I'm correct. Oh yeah, this is either 1 or 7. Yeah, and it can't be 1. So there's a 1 here. This is either 1 or 6. 5 or 6. And this is 1 or 5. Now that's gonna be interesting here. This sees 2 here, so it must see 3 here. Oh. Yeah. Two, 3, 7, 9. Well, this can't be 9. There's a 7 here. Yeah, these are not 9. This 3. And these are not 7. So, and what did I say had to happen on this 7? This can't be 9 now. Oh, it couldn't because of this 3. So, this is 9. Okay, so this sees 3 in this direction. 4. There's a 9. Oh, 6, 7. Right, okay. So this must be... Doesn't this have to be 7 now? Because it must be higher than this. Because this is... Yeah, it must be higher than 6. So this is 7. And... Okay, 7, if it's not... Five. Oh, where does 6 go in this box? Just by Sudoku, it goes there. Now, what about this? What's frustrating is that none of the possible... Oh. Oh, yeah. Ah. Right, so there's a 1 up here, so this is 6. Oh, it is? I mean, I can't put a 7 here. To the southwest. Oh, here. Yeah, the 7 could be after the 9. Can't be here. But this can't be a 9 either. The fact that I've gone so long without anything breaking makes me suspect this is actually the correct solution. But the trouble is, like, even if we arrange it the other way, none of these are actually seen directly by any skyscraper clue, because everything gets blocked off long before it gets here. There's a 1 here. But it doesn't matter what I put here. Or here, because nothing can be higher than that. So the 9 has to come before the 7, or the 7 could go up here. That also works. I'm just not seeing... Okay, what about the 6? It sees either 1 or 2 here. Sees at least 1 here. This can't be 7, 8, or 9, so it has to see... Okay, this sees at least 2 here. At least 1 here, at least 2 here. 3. This has to be less than 2 here, 2 here. It has to see 1 here and 1 here. So I think if this is correct, this is forced. So it has to see exactly 2 here.
Alibi. I'm getting tired of all your alibi.
Oh, this is a naked 5.
Telling me that I shouldn't doubt when you're not about.
Wait.
But then your ever loving always finds you out in those alibis. You're always giving me those alibis. Well, let me tell you this.
Oh yeah, it needs to see one here and one here.
Mother's knee. My father gave the same excuses you're giving me. So save those lies and all your alibis. All of your alibis. I'm getting tired of all your alibis.
This feels... No, I think this is broken, because now this needs to be...
When you're not about, but then you're ever loving always fine.
This needs to be in between... But it can't be.
Let me tell you this, you ask me to believe that you're
Oh, what? This could be 9, right.
but seeing is
In fact, it has to be.
I never see you, so save those lies and all your alibis. Alibis, I'm getting
So this is 6, 7, resolved by that.
You're always telling me that I shouldn't doubt when you're not about, but then you're ever loving always fine.
9 in this box goes here. The fact that this is all just one big bifurcation makes me strongly suspect that... But it would almost certainly be eons before anything broke regarding these. Maybe that's... What's... It's 2, 3, and 4 left. This isn't 4, this isn't... Oh, this isn't 3 or 2. Okay, so this is 2. So this is 3, this is 4. So that's 4. Oh, 6 in this box goes here. Huh? 5, 7. Let's see, okay. 4, 5, 7. That's 5. That's 7. That's 4. Okay, and now 2, 3, and 5. That's 2. 3, 5 pair. Could go either way. Oh, it is? Oh yeah, it can't see the 7 before the 9. So that has to be 7. Because it's the only place for 7 in that rank. And this 5 looks down here, makes that a 3 and that a 5. One in this box, 2, 3, and 7. I've only got 2 and 3 left down here. Oh, that can't be 7. That's 7. So this is 2, 3. This is 2, 3, 4. Oh, 9 in this row goes here. And since I know this sees exactly 3, this must be in between 7 and 9, 5 and 9. Oh, this is 1 in this box. That leaves 2 and 6. And 3 and 5. Is that resolved by... Oh, not yet. Okay, I've managed to... Okay, this is... this is... Yeah, and this resolves correctly no matter what we do. Okay, so, what about this? This sees 2 here, 1 here, 1 here, and it sees 2 here. This is 5, 6. This is 5 or 6. This is 6 or 7. And this is... Oh, this is 5. That leaves 3 in this row. Oh. And the rest is just... Oh. Yeah, it says... Oh! Oh, wow! Okay, certainly went all out for this. Okay, well that was gorgeous. Indeed. Yeah, that's a crazy amount of work. And I just thought of a way to make something far eviler with this premise. I might do that myself. We'll see. Yeah, the interface, top-notch aesthetics. I would like to know exactly how I was supposed to deduce which of these were parks, because it's just so symmetrical that... Like, okay. I suppose I could do, like... I guess I could have gotten all of this down to, like, this had to be 5, 7, 9, 7, 3, 9, 6, 3. Yeah, maybe it immediately breaks if I make this park. Probably. Okay, let's see if I make these... Like, okay, if these are park, that makes these 8. So this has to... This can't be 8 or 9, so it must be something less. Okay, so this sees... And this 3 prevents this from being 9, so this must see at least 2. This sees 2, 2, 4, 5, and 4. But I could just put a 9 here. Make that a 2? I guess I have to in that case. Oh? It sees at least 2 in this direction, at least 2 in this direction, 1... It has to see exactly 1 in this direction, that's 5, and 2 here. Yeah, if it sees 2 here... Yeah, so it has to see 2 here. So there must be a 9 up here. Can't be here, so it must be here. Because I know this sees exactly 1 here. I know it sees at least 2 here, so it must see exactly 2 here. Because it sees at least 2 in each of these directions. Okay, this needs to be less than 4, so it's 2 or 3. And this is either 1, 2, 3, or 9. This sees 1 this way. Sees something less than 8 here. Oh, it sees 2 things that are less than 8 or 9 here. Maybe it's this that breaks. Oh, and neither of these can be 9. Or can this be 9? Doesn't that... Maybe it's this. Let's look at this. One of these needs to be a 9. The other, does it need to follow up with a 9 right away? Like, if this was like, I don't know, a 6, could this be stuff that's less than 6 and then see a 9 here? Could these be from 2, 3, 5? For that matter, I'm not sure that wouldn't have worked the other way. Oh, the corner 6, right. Let's see. This can't be 9 or this breaks. Because this needs to see at least 7. So it sees at least 3 here. And it sees at most 3 here. So it must see at least 3 in this direction, so this can't be 9. This has to be 9. Okay, and now I think we're in trouble. Right? Right, this can't be 6. Right, this all... either have to be both. Right, this, yeah, this has to be 9. And now, doesn't that break this? Neither of these can be 9. It sees 1 here. Two here. One here and 3 here. Okay, yeah, so that does break. Okay. Okay, that does break eventually. That is not... It did take a while, but... Okay, and then I just do the rest exactly as before, but I will do that on my own time. Yeah. Okay. I don't think that broke immediately, but... But it did break reasonably quickly. Alright, so this can't be 9, so these... Right, the one up here, it forces that to be a 1 even before. Yeah, the rest of it was... was neat. Ah, c'est la vie. Alright. Well, I'll try the rest. Oh, you asked in that thread. Okay. Well, let's move on. I got a couple more in the queue. From Dorlier, the next Topo, and then Phoenix. Alright. Well, that was fun. Now this is interesting. Oh, I do need to refill my water again. But, I'll be right back. All right. So, normal Sudoku rules apply. So every row, column, and box got to put 1 to 9 once each. Quadratics. Of the 4 digits on a circle, 2 of them are the two solutions of x squared minus ax plus b equals 0, where a and b are the other 2 digits on that circle. If the equation has only one solution, that digit occurs twice. So, to solve x squared minus ax plus b equals 0. Okay, to factor it, you got x minus a plus b times x wait, okay, wait. So a and b, x minus y, okay. I'll solve this, okay. I'll introduce two new variables. Y plus z equals a, if I remember my quadratic formula correctly, and y times z equals b. For this equation, because like x squared minus 9x plus 20, that's x minus 5 times x minus 4. So, what we're looking for is, for a and b, y plus z equals a and y times z equals b. So we're looking for factors of b that sum to a. But of course you can't multiply two. Oh, where... Okay, so the two solutions are one where x is equal to y, and the other is x is equal to z. Okay, so basically what we're just looking for is two factors of b that sum to a for each of these circles. The 4 digits around each of these circles are a, b, and two factors of b that sum to a. Now that'll probably be easier in the circles that are contained entirely within a single box. So what can we do here? Two distinct numbers. They all need to be distinct numbers. So, 8, 2, 4, 6. Yeah, 8 and 6 work. So this could be 2, 4, 6, 8. Does anything else work? What about 6? 2 and 3, 5. Okay. 2, 3, 5, 6, or 2, 3, 6, 8. Let me open up the notepad again. Two, 3, 5, 6, 2, 4, 6, 8, because 2 and 3 sum to 5 and multiply to 6. Are those the only things that work? What if there's no 2? 3 and 4, oh yeah, it needs to be, and it can't be a 1. I can't get 1 involved in y and z, because then I'd have a repeat of z. Then b would be equal to the other digit, and I can't have repeats. What about, oh, and 2, 5, okay. So each of these circles is either, you took a nap and who was still solving it? Who's they? Oh, and these must be different. Because otherwise I'd have 4 digits that need to go here. Puzzlebee, John, Crusader, and I think Nate. Okay. But I do have 2 and 6. So around each of these. So this must be 2, 6. And this is either 3, 5 or 4, 8. And whichever... These digits either go here or here. I also have... Oh, this must also be green. So I have 2, 6, and I also have 2, 6 here. It'd probably be easy around here. Okay, what if I can only have... What about ones with repeats? What are the options? Oh, then we get into ones. 1, 2, 3, 2. Yeah, once we get into... Although I can't have more than 2 of these of a 1. What about, wait. Can have ones, 2, 4, 2, 4. 2, 3, 5, 6. 3, 3, 6, 9. That also works. So this digit must go here. Oh. Okay, so this one's important because it can't have a 2 or a 6 on it. So it can't be 3, 3, 6, 9. Could it be 1, 3, 1, 4? Okay. If y and z are the same, the only way y and z being the same works is if it's 2 or 3. But neither of those work here. So there must be a 1 on here. Y or z equals 1. So it... And z cannot be 2 or 6. I guess it could be any of 3, 5, 7, 8. Oh, it can't be 5. Okay. This is either 1, 3, 3, 4. Oh, but I can't have 2 3s on here. Or 2 8s, because that breaks these. So it's... Wait. Is the only option 1, 7, 7, 8? Oh, sure. But I think... It can't be 1, 3, because I need another 3, and that breaks one of these. Can't be 1, 4, because I need another 4. Yeah, this... Okay, that is a really clever break-in. Because this is 1, 7, 7, 8, and each of these must be a 7. Now the 8, whichever of these is an 8, it goes with... Okay, so there's a 7 up here. And whichever of these is an 8, it goes with the 2, 3, 5, 6. Oh, if this is 8... If this is 4, 8, does that... Means there's a 4-8 here or a 4-8 here. If it's here, that's 8. If it's here, that's 8. Okay. Now, what is... I can have at most 1 of 2 or 6 here. I can't put a 7 on here. Oh, and there's also this. Like, what is this? Oh, this can't be the same as this. I don't think these can all be different. Okay, maybe I need to look here, because... Okay, this could be 3369. Or this could be 1. Three, 369. Now, if this is blue, this can't be blue. Could this can't be too... Yeah, that is how factorization works. That DM, did you send that to me by whispers or on Discord? That's... No, I don't think there's any chance this is 7, right? Well, maybe, like... One, 7, 7, 8... No, that can't be, because this... Can't have another 7. If this is 7, I think that breaks, right? Oh, thank you. Cool. Okay. I'll split the ones into their own. I'll sort by lowest digit. Okay, so these are the only combos. Okay, and the only one of these that has a 7 is... It either has 2 7s or 2 6s. So, and neither of that is possible here. Now I know this is 1778. Now, either this... I think this has to be 1 or 9, right? Because either these are 3s, this is 6, this is 9. This is either 3, 3, 6, 9, or this is a 1. And either way, this digit... Either way, this digit goes here. Wait, that's not possible. Oh yeah, it is. So this is blue. Now 4 and 5 don't go together. So if this isn't 3, oh, it could be 1, 3, 3. No, 3 and 4 also don't go together. Yeah, so it's 5, 6. So is this always 6? So this is either 1556 or 3369, and either way, this is 6. Okay, so there's no 2 there. Oh, and in fact, we now know... Oh, but we don't know which way around 2 is. Yes, we do. It's 2, 3, 5, 6. Okay. Oh, so this can't be... Okay, so this is 2. So this is 2, 6, and this is 4, 8. So this is 7, 8. And this is 1, 7. Now, if this is 1, there's 1 here. That's a 1. And then... Ah, but if this is 9, I then can't put 9 in this box, so this has to be 1. Four, 1, 4, 9. Feels like I should be able... Well, that's not 1. So this is 3, 5, 9. Oh, this isn't 3 or 5. This is 9. I can narrow this down more. So this is 3, 5, and now this is a naked 4. The 7 in this box goes here. No worries, Banks. Oh, this is also, oh, this is 9. So 7, 8 pair appear. This being green would be interesting. Of course, it being blue would also be interesting. Let's see. There's only 2 of these that contain a 9, so if this is 9, it's either 1889 or 3369. Neither of those works, so this is in fact a 1. And these 2, don't these have to be the same now? Yeah. Yeah. Wait, what's wrong with 1, 1? Oh no, they multiply to 1, so I need 3 ones. That's not allowed. Okay. That's 2, that's 6. So that is 3. Okay, so this is green. So this isn't... Oh, there is a 4 here. And this is 2, 4, 8. This digit goes down here somewhere. So this... Oh, can't have a 2 down here, because then I can never put 2 in this row. Can I do anything else? No, I cannot. Five in this box goes here. Oh, so does 1. So this is a 1-5 pair. So this is a naked 9. Yes, yes they do. And, yeah. Ah, the only ones that have a 9 are 8, 8, or 3, 3. These must be 8. This is also all the odds. This is 3 or 7. This is 1, 5 or 7. Okay. So, well, first, 6, 7, 8. This is only 3 or 5. This is only 2, 3, 4, or 5. This can't be 1, 2, 3, 4. This is only 5 or 7. So there's a lot of odds here. In fact, I do believe... Yeah, it's not possible to have an option here with no odds. So this must be even. And, okay, so this is 2 or 6. Now, if these are all... Oh, these can't all be different. So there must be a repeat. These have to be the same? So the only repeated 5 goes with 1 and 6. These are all from 2, 3, 4. I'm very curious how we're going to... Oh, what about this? 1, 2. 7 and 8. And that leaves 3, 4, and 9. Here, okay. So, if this is 1, 6, this is either 5, 6, or 6, 7. Oh. Are those the only options with 1 and 6? Yes, they are, and neither of those works here, so this is 2 and 6. Honestly, I probably didn't even need to copy this down. I could have just spent a couple minutes making it myself. Okay, so 2 and 6. 3, 5, or 4, 8. Are those the only options? Well, it can't be 3, 5. So if it is 4, 8... Yeah, those are the only options with both 2 and 6. Okay, yeah, so this is 4, 8. Oh. And it's resolved. And it resolves these. Okay, so what about this? It can't be... Two, three... 2, 4... Can't be 2, 4, 6, 8. So if there's a 2 on here, it has to be 2, 4, 4, 4. So that'd be it. So those would be 2, those would be 4. That would resolve most of this. But if there's a 3, 4, it'd have to be 1, 3. Oh wait, these. The only thing with both 3 and 4 on it is this, which immediately breaks because this can't be a 1. So I think this does have to be... that... 1, 5, and 9. Oh, this is done. This is 3. Okay, and now let me think about 3s. Oh, what about 4 and 6? And this 2 and oh, that's 2. And then 9. Oh, that's gonna, well, it'll at least resolve a few things. It doesn't quite get anything. Okay, what about this? 3, 5, and 7. That's not 3, that's not 7, that's not 5. Okay. But this... 7, 9, okay. All the circles are filled, so it must just be Sudoku from here. This is 1 or 6.
Let's go.
1, 5, 6. Okay, it's not 1. This is 6, 7, or 9.
Luigi number 1. Here I go.
If this is... Oh, is there a... Oh, is this the one, like, where I mentioned a Y-wing? See, okay. If this is 6, this is 1, this is 9, this is 7. This is 7, 9, 5, 1, 6. If this is 9, 7, 1, 6. Or is it... 9, 5, 1, 6, 7, or 7, 1, 6, 9, 1, 5, 9, oh, 3, 9, 4, 3, 5, 1. Oh, wait. Is it this? If this is 9, this is 5, this is 1. If this is 7, this is 3, this is 5, this is 1. Okay. That was neat. Yeah, these quadratics are... They had a hidden green there, too. Ah, the good old days of algebra. I say good old days. I hated every second of school. But, yeah. This was fun. I'm amazed that it's actually unique with just these. This is one of those that where I'm amazed it's actually unique with just these and nothing else. No other clues or anything. Yeah, that would be... yeah. Alright. Okay, and another topo. This one with Erwish. Are there any others? Topomino. Alright, I'll add that to the back of the queue over here. Alright. Oh, I should pin a link to this as well. Alright. So this is topo. So I draw lines to divide the grid into regions, and lines cannot branch or intersect. Some lines are given. All cells of a region must be filled with the same digit, and digits in regions that touch differ by exactly 1. A clue on a line is a value in between the digits it separates. For example, 2.5 would separate 2 and 3. So this is a 1-2 pair, and this is a 7-8 pair. And also, each gold wheel has a different digit. How many of these? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there's 8 of these. And I can also, because of this, I can't put lines here or here. So these must all be, and these are 0, 1, 2, 3. I can have zeros. Now this, one, 2, 3, 4, 5, 6, 7. If this is 1, this is 8. These must all be. But this. So these must all be part of the same. Now, I don't have many degrees of freedom in here, but I do have. Alright, also. These must be part of the same region. Okay, so. As must this. Okay, so, but these must be different. And since diagonally adjacent cells can't differ by 2, because you'd need 2, so these must all differ by exactly 1. Well, this must be 1 apart from each of these. Must be strictly ascending or strictly descending. I'm guessing, because of this, I'm guessing that means they're ascending in this direction. Can I do something with parity? Like, I know this and this have the same parity, and this has different. I also know that this either takes both of these or both of these. If it takes these, it must also take these. So this run of 3. Oh, there's also these. So these are part of this region. I guess I can't close this unless this is either 0 or 9. But I don't consider that terribly likely, because if I close this, I can never resolve whether this is higher or lower than this. But I don't want to use uniqueness, though I might if I can't spot anything else. Okay, what about... This either takes these or this. Because if this is cut off, this goes this way. If this isn't cut off, this... I guess it could take down here. There's only 8 digits and there's only 8 wheels and I have 10 digits to work with. No, it's right after this. Also, welcome, Phoenix.
Thanks a lot. That was kind of out of the blue, huh? So I guess it didn't make any sense. I'm lonely, but I don't.
Let's see, I know this is a run of 3 consecutive digits. Does that...
That's how I interpreted your song.
Oh, neat.
Yeah, you got it right.
Where is...
Here. Whoa! Words popped into my head when I heard.
So I don't need to put everything in a digit. Can I say something about... Okay, what's the maximum difference of this?
What we're missing.
2... Oh, and this... I think these have a maximum difference of 2? it's kind of bifurcatory to see, because like I think one of these two, either this takes this or this does. Yeah, this can only be either the same as all this or the same as all this. And the same goes for this. Perhaps more importantly, this. Yeah, these differ by exactly 1 or 2, I think. So that does cause so they can't be like, they can't bracket these. What is more? The only way these differ by 2, I think, is if this is sort of by itself and there's a buffer like that, or can that be more than 1 digit? Oh no, I think these could, yeah, there is a way for these to differ by 3, but there is not a way for these to differ by 4, I don't think. So I think something like that. And having that be its own thing, that does allow these to differ by 3. But I don't think I can make that... I don't think I can make that any bigger. So I think they either have to be both higher than all of these or both lower. Basically, this has to be quite a bit more than this. So... guessing this is like the lowest possible, or probably, but how would I prove that? And also, like, obviously this can't be a 1-cell region or these would be the same. So it must either go like that or like that. Obviously I can't... If it goes like that, it's the same as in here. So I can't reach this with that or this. What if it goes like this, though? That is far less forcing in terms of this region. So what's the... When do I... If this take that. What's the maximum difference between this and this? Since I know that this takes either this or this. And if it takes this, then this takes this. Either here or here, so each of these must be at most one different. One of these must be in here. So this could theoretically be as low as 1, but like having this be oh, max difference of 2 and max difference of 3. So all of these must be either higher or lower than all of these. I'm guessing higher. Especially because, okay, these must be in between. This is at most one different from. What is the max difference of this and this? Max difference of 3 from each of these. And these must differ by exactly 1. So if they... wait. So if this takes this... God, this is confusing. What... So if this goes like this, and this is part of this, what do I know about? I know it's not the same as this. I know it's at most one different from this. How is it? How are both of these higher than this if they can't, or lower if they can't? But doesn't that work both ways? Like... Okay, maybe not, because if this... Max difference of 3 here. Max difference of 4 here. So, if this is all one region, it's a max difference of 2 here and 2 here. And they must both be higher or lower, so one of them must be differ by 1, the other must be 2. Okay. But then this... Okay, that doesn't work. So I think that is forced. I wish I could check to make sure, but okay. This now has a max of 2. I'm pretty sure, like, these must be 1 and 2 apart. Like, these must form a run of 5 consecutives. But wait, what is the max difference between 1, 2? Max difference of 4 from here. Maybe I was wrong about these pencil marks, but I can't see. Oh yeah, there's a max difference of 5 between here and here. Maybe that's the key. And then... maybe this does reach down here and take this? It is so difficult to prove any of this, though. And what does that mean for... okay, this is a max difference of 1 here, max difference of 2 from here. Okay, if I make this... if I make those all ascending, that does mean this has to... this doesn't seem... okay, what am I missing? Max difference between here is 3. Max difference between here and here is 3. Max difference between here and here is 2. And max difference between this and this is 2. So max difference between here is 4. This cannot be... okay. Right, I can do... 2, 3, 3, 3. So this cannot be more than 3 different from any of these. And it can't be more than 4 different from this. Maybe I can do parody. 'Cause like... this either goes here or here. This either goes here or here. So I know these have the same parity. So, these have a max, yeah, it's pretty easy to see that these have a max of 4. Max difference of 4. Wait, if they have a max difference of 4, they could be... This goes here or here. This goes here or here. So in actuality, this has a max difference of either of these of 1. Can be at most 1 different from either of these. And since they differ by exactly 1, this must be one of them. Oh, unless this is its own thing. So this could be 2 different, 1 different from 1 and 1 different from 2, but either way, because this either goes here or here. Yeah, so these do have a max difference of 3. So yes, I am back to these having to be all on one side of this. These must either both be lower or both be higher. Now, if this takes... I could close that and make that its own thing. That would still put something one away from this here or here. Yeah. Okay, what if this is all here? I don't see what I meant to do here. Maybe... This feels... Okay, what about... For this to be... Wait, this can't be 4. Like, for this to be 6... Oh, this cannot be... Yeah, this can't be 6. So this can't be 5. Similarly, this cannot be 6. In fact, this must either be here or here, right? This, okay. So, oh, and this... There's no way for this to be 5, right? This is 5, 6, 7, but then being enclosed on all sides means this... Oh, unless this... No, this... Yeah, the minimum this can be is 6. So this is either the same as this, or this is the same as this, or I guess both. I guess I could put 6 here. One of these goes here. This either goes here or here. One of these goes here. I can't see what... So what happens next? These any different... I can have at most 2 different, like, digits in here. Oh, this cannot... Right. This has to keep going or else that... but it can't reach this. Oh, and it has to have... Okay. Duh. Okay, okay. So that's what... But this has to be different from the... Oh no, this has to be the same as the... Okay. Because these can't touch each other. Okay, so how does... Oh, this has to keep going this way. And one of these, at least one of these has to be red. If this is red, then all of these are red. If this is yellow, then, well, okay, so this is one of these 2. This, oh, if this is red, then this is yellow. If this is yellow, this could be either. So these differ by 2. So at least one of these is yellow. But these can't both be yellow. These could both be red if this is yellow. Oh, if this goes down... Oh, if this goes down, that breaks. Because this would be at least 5, 4, 3. But I can't have this be that different from that. Okay, so this is yellow. So this is red, and this can't be closed off, so this becomes that. And now these can't join up. This is too different from this. And it's a max of 2 different from this and this. 1, 2... I have broken something. Because this is a max of 1... This has to now be exactly 2 different from all of these that all have to be different from each other. So, given that I am... These has to be 5 different digits that differ from this by 2 or less. That is not going to work. Okay, what if... I think that's all... Okay. Maybe I was... The only other thing I can think of is maybe if it does this, it now has to once again differ from all of these by, oh, but wait, that's actually not terrible, because now it leaves more room for this to... this, wait, but now it's, okay, we run into the same problem here, so I think as it stands, I do not know how to solve this, and in fact it seems obviously broken? Yeah, this puzzle seems like obviously broken as it stands, because if I do this, obviously I can't close that off there, so that has to... Now that's forced, but this... Okay, maybe I should just omit these pencil marks, because now... Oh, wait. If this... Yeah, I run into the same problem, where, like... I can't... The minimum this can be is 6. Okay. Yeah, I've seen Chatty Cathy do that a couple times. I haven't looked into it much myself, but it does sound neat. Because now, like, whichever way I resolve this, it breaks immediately. Oh, wait. I don't necessarily have to make this... Right. I don't have to extend these in this direction. If I do this, I do have to do that, but then I can do this. That's still fine. Okay, but now we're back to me having absolutely no idea how I'm even supposed to begin to solve any of this. I may need to ask Juggler for... Oh, with community people. That sounds... cool. Yeah, if I don't... I may need to ask Juggler for a hint, because... I can't... been staring at this for 45 minutes and I don't feel any closer to... I mean, I know that it doesn't do that or that. So, can this... Is there any realistic chance that this is not... Yeah, no, this is either the same as this or the same as this. So, minimum this can be is 5. And in fact, I don't even think it can be 5, right? Because this... Oh no, that... this is also 7, 8. Yeah, the minimum this can be is 6. This is a run of 3. Oh, and this cannot be more than 3 different, sorry, from this, this, or this. Max difference between this is 3. I guess it's possible this and this are on the opposite side, but that would be... No, because the max difference... No way. No, because it's not... Right, these are all on the same side. Okay, so... These form a run of 6. I know this goes up here or up here. And this goes up here or up here. So this is a max of 4. Max of 5. This can't be 9. But I can't do that. So yeah, these do have to be strictly ascending in this direction, as I suspected. And these all have to be less than that, so no 7 here. Oh, and this... Yeah, these do have to form a contiguous run.
I'll even change the number hanging on my flat, because nobody loves you when you roll and gray. There'll be some changes made today. There'll be some changes made.
So it's either 2 through 7, 3 through 8, or 4 through 9. But if it's 4 through 9, that breaks, so... So it's either 2 through 7 or 3 through 8. Oh wait. This has to be... so close to spotting it. Oh dear.
I don't want you, but I'd hate to lose you. You've got me in between the devil and the deep blue sea. I forgive you, but I can't forget you. You've got me in between the devil
This
and the
goes
deep blue
either
sea.
up here or up here.
I ought to cross you off my
This is
list,
the most
but
one
when you come
way.
knocking at my door, fate seems to give my heart a twist, and I come running back for more. I should hate
Oh wait.
you, but I guess
8.
I love you. You've got me in between the devil and the deep blue sea.
So how do I resolve which of these is which? And the fact that this... Right, if this is 6, this is 9, so this has to be 5. I think these must differ by exactly 4. This goes here, here. So these are at most one apart. Like anything here is at most one apart from anything here. So I think that forces this? I think. I think 5, 6, 7. Oh, yeah, this. Oh, and this. I can't close this. If this is crossed, this also has to be crossed. Oh, and I can't do this because then, yeah, okay. These do have to be the same. So if these are 6, 7, 8. These are, there's 5s here somewhere. With a 4 here. Oh, but wait, these also have to come over here and form these, don't they? Because otherwise this has to, like, if this is 6, this is 7, 8, and this is 8, but now, oh no, this could be, yeah, 7, yeah, the 6 coming up here, oh, that does work, annoyingly. These are either a 2-3 pair or a 3-4 pair. There's no 5 in here. So these differ by 1. But I don't think this can be too far. Right, this has to differ from this. So this needs at least, this has to differ from this by at least 2. So, and because of this, there's only so much, oh, unless it takes this and this. And this just gets cut off from that by, well, unless this is, oh, there's so many different, there's still so many different ways this could go. This can't be 9 at least. Oh, and this. This being 8 makes this 7, this 9. 6, 5. That's fine. What about... This is... Also, how am I going to resolve whether this goes like this or like this? I assume there must be something. Can I do... Oh, I can do parity. If I am in any way correct. Okay, this must be this. And this must be this. So in fact, this must be this. Does that mean... Oh, but this could be the same as this. But I know that this... Yeah, this doesn't have to reach this. It could, but I don't think it has to. I think I know that this is the same as this. Yeah, it is. This is the same as this. Oh, and the fact that... Wait. Oh no, this isn't forced. In fact, I think it actually works better if it doesn't... Yeah, this is gonna... I think this is... Is that forced? But then how would I ever... Oh, this... Yeah, this doesn't take that. I think it's gonna turn out to be that. I just don't quite know. This... No, I could still see, like, this could take this, but it doesn't have to link up to this specifically. There's still... Oh, but I think... Right, if this... Oh. Oh, wait, no. No, that wouldn't necessarily... Oh, I'm so confused. Oh boy. Where is it? Okay. I know this goes here. It's either here or here. So it makes two of this. So it must be exactly two of this. So this must be red. Jesus Christ. Really? Or wait, no. But I thought I couldn't do that. Now this has to be here. But this, I can't make these the same, so these have to go up. I can't make these the same, so this has to go up. And this has to go down. But now I can't, this has to, what? Okay. Okay, so this is forced. Alright. Oh, wait. Okay. But this can't, okay. Okay, so this has to be 4. Okay. That makes this 3, and this 2. So this is also 3. So this is also 3. This can only be 3, 4, 5. Can't be 5, so it's 3 or oh, if it's 3, yeah, that breaks. So this is 4. Okay. Okay. Alright. Oh. Okay. This. Okay. Oh. And if that closes, those link up, which would be bad. Oh. So this now becomes 6, 7. So this now becomes 7, which joins up there. And this is 6, and this is 8. This is also 8. This has to keep going. All right. Yeah. Took me entirely too long to get this far, but I did eventually. Okay, and now we have a... Yeah, there was probably an easier way to spot that these 6 all had to form a virtual Renbon, but I got there eventually.
Is that my mail?
Yes, I probably did find a harder way. So one of these is 2. Oh, one of these... Okay, so this must be 2. This is 1. Oh yeah, I found that was how I proved it. I didn't update my pencil marks over here. That was how I proved that these were exactly 4 apart, with these in between. It was reasonably smooth once I found that. It took quite a bit of... It doesn't? Okay. I might have found. Wait. No, this must be 2, this must be 3. For this path. This must be 3. This is 4. Yeah, I sorta... In my defense, when the only other clues are an Erwish set, I did kind of think they were meant to be important throughout the solve, but... Okay, and now this... This is 3 by the diagonal meta. 4, this has to keep going. And this is 3. This is 2. Oops. I mean, I can relate to disambiguators ruining a break-in. I've been... wait. Oh, is this... Okay, okay. I totally missed that. Okay, that's 4. Okay, so now this becomes 3. Simply by diagonal... Oh. Right, okay. Okay. All right.
Farewell, sweet cookie cat.
And let's finish up with a
The time we spent together.
with this 2-star from Phoenix. Let me pin a link. All right.
Hush now.
Normal Sudoku rules apply, so every row, column, box must place 1 to 9 once each. Digits placed on renbans must be a non-repeating set of consecutive digits. We got killer cages, so these must sum to 13, these must sum to 7. Separated by a white dot must be consecutive. each light blue line contains exactly one unique digit. All possible lines are given. For the avoidance of doubt, each line goes straight and does not bend or branch. Okay, so these... Alright, well, let's... This is 7 cells, so these are 1, 2, 8, or 9. And I can't put 1 or 2 in here. 7 consecutive digits must use everything between 3 and 7. So because that's 8 or 9, that is 4 or 5. So where does this digit go in? Possible lines are given. That is, so basically anytime 2 of the same digits are a chess king's move away. So like this. Oh yeah. The outies in each of these boxes are 1, 2, 8, 9. So this is also 1, 2, 8, or 9. Ah, so... Ah. Okay, if this is... If this is 1, this is 2. If this is 2, this is 1. If this is 8, this is 9. If this is 9, this is 8. So the outies are either a 1, 2 pair or an 8, 9 pair. This oh yeah, because this also goes here. So this is consecutive with this. But this can't be 1, 2, 8, or 9, so this is only 3 or 7. So this is 2 or 8. So this is 1 or 9. And these are the same polarity. So these are also the same polarity. Oh! Oh, so this is a 3-7 pair. Oh, 3, 7, 2, 4, 6, or 8, but... Okay, so there's no 2 here. Oh, there's a 2 up here. It's not here, it's here. So this can't be 2 or else this breaks. So this cannot be 8. These are from 4, 5, 6. So these are also from 4, 5, 6. And these have to be 3 distinct digits. Might be interesting, because, okay, I can't put 6, 7 here, so this is 5, 8, or 4, 9. Now, this can't be 3, 7, and, oh, where does blue go in this box? It goes here. Oh, and this, right, these can't be 2, 8 pairs. Right, so these are 1, 9 pairs. Okay, so there must be a 1 here. Oh, so this must be a 1 and a 9. Can pencil mark 1 in row Oh, right, it can't go down here. Okay, this must be the 1 in row 3. There's a 1 in here. Okay. Yeah, that's, oh, okay. 1, 9, 2, 8. This is gonna... Yeah, this isn't 9 because it's the only place for 1 in this row. Thanks to this white dot. Can't put 1 here because couldn't be 2. This. Oh, I have an X-wing on 9s, so that puts a 9 here. So, doesn't this have to be 1, 3, 9? That's not 3. There's a 3 in here. If it's in here, we got a 4 with it, or a 2. Yeah, it could be either. Oh. Maybe I should... This can't be 1, 9, or 3, 7. This can't be 2, so this can't be 8. Now, if this is... Oh, I can't put both 4 and 8 in here anyway, so that won't worry. I do have a virtual 4-8 pair here. And here. Oh, does that mean these are the same? Yeah, I think these two go in here. Because the other of 4 and 8 is in here. Because of this. It can't be 1-9 or this has no value. So this, it has to go in this row. This is 2-8. This is 4-9, so this is 6. This is 4-6. This could go here. Been there if... Oh. Yeah, uniqueness of lines. That's gotta be important, because, like... I know this can't go here. Oh, these have to go here. Or, wait, no, this could go here. Then there's... Oh! 1. There, that gets me that. And similarly, 9 could go here, here, here. And then... then this can't be a 3. So there's a 3 in here somewhere. This is a different... Oh wait, this digit goes here. Ah, and it's 8. So this can't be 8, so this can't be 5. Oh, 1 in this box only goes here. 5. Oh. One, 1. So that's there's 8. And the remaining 8s go here and here. So there's 9. There's 9. This can't be 1, 6, so it's 2, 5, or 3, 4. This digit is the same as this, and it's here. Let me see if I can... chase that around the grid at all. Where does this... This goes here or here in this box. Oh, free rows. Yes. Yes, that is 2. Which makes this a 2, 5. This is 4, 6, 9. So there's a 9 here, a 2 here, what about oh dear. Right. Yeah, I can use this. Right, this allowed me to... Okay. Let's see. Okay, and then got five here. This must go in one of these spots here. 9 can only go here in this. Where does 9 go in this column? Oh, it's in one of these. Oh, 9 must go here in this box, so it can't go here. So in this box it goes here. That's 4, 6. Okay. Oh god, there's that Tumblr post going around of a bunch of Muslim TikTokers posting their cats being very confused and sleepy as they get up at as they get up, as the family wakes up at unusual hours for their holidays. Yes. Yeah, it's adorable. Yes, so what's left? 1, 3, this is 3, 4, this is 6, 7. Oh. This digit, oh, well, I already know this is... Okay, let me... Blue must go here in this box. Oh, it goes here. Okay. What about... Green must go up here. Oh, this is blue. Okay. Blue in this box goes in one of these spots. What do I know about where it goes in terms of... Alright, good night, Dorlair. Oh, well, this is just 2. Oh, that's 2. And this is 9. So that's 9. Okay, that's what I was missing. That's 8. That is... Cool. Okay. That is... 9, 2, 6. Okay. Yeah, probably, yes. Yeah, I should have. Three, 4, 6, 7. This is obviously not green. Oh yeah. Wait, why can't this be a 3-4 pair? Oh. Right. Okay. This digit in this row has to go on here. Wait. This digit in this box has to go on here. It's this digit. Okay. Okay. So this is either 2, 3 or 4, 5, 6. Right. Okay. So that's a virtual 2, 5 pair. Four, 6, 7. Oh, wait. This is 5. This is a naked 5. Three, 4, 6. So there's a green up here. This is... this, okay. One of these is this digit. Oh, there's a 5 here. So no 5 there. Okay, so there's a 5 up here. That's 5. So that is green. And that is 3. Ah! So there's a 5 here, makes that a 2 and a 5. That leaves 2 and 7 down here. Oh, this 2 makes that a 4. Okay. Okay. Four and oh, okay. This one's about doubles. Two, 9, 1. Each one appears to be about a different digit. Oh, hey, TVDK, welcome. Alright, this is 5. That's 6, and that's 4. Oh. Gotta fill in these 2. That's 3, that is 4. Okay. I don't know what I would guess. Okay, in order they were posted, the themed, it seems to be 2, 3, 2, 9, and 1. Okay. Well, they've all got killer cages. Oh. Oh, they all have the same solution. That's actually really impressive. Huh. Neat. Yeah, with this ones thing, that would be really difficult to do with a grid that had to all be. Huh. That is actually really impressive. Yeah, that's neat. Okay. Yeah, that was a neat setting exercise. Yeah. All right. That is it from me until Monday. I won't be on this Saturday or Sunday, but oh yeah, that is. I won't be on. Oh, it's kind of like a Paradoku almost, but triplet. Yeah. Okay. Let's see. Alright, well, Tangle and Whisper just got released for Sonic Cross Worlds, so I'll send you over to Skulls, who's streaming that. And I'll be back with more puzzles on Monday. Alright, so thanks for joining me, and bye!